Hello everyone, welcome to another Leetcode video. Today we're looking at the problem get equals substrings within budget. And this question reads that we are given two strings, s and t, and they have the same length. We're also given an integer max cost. So we want to change the string s to the string t. At any point, we can change the ith character of s to the ith character of t with this operation. We could do it by taking the absolute value of the character at s minus the character at t. So we want to return the maximum length of a substring of s that can be changed to the same as the corresponding substring of t, with a cost less than or equal to max cost. So the description's a bit of a mouthful, but I think we could simplify it a little bit. So if we look at this example here, essentially what we want to do is find the maximum substring in S that we can change to match the same substring in T. We want to make sure that doing this, the cost of our operations is less than or equal to this max cost. So looking at this example, we see that we could take this A and we could change this to a B. And this costs us, I imagine these are 0 through 26, all the letters of the alphabet. This would be the absolute value of A minus B, which equals the absolute value of 0 minus 1, which equals 1. Likewise, for B, we could do the same thing. We do the absolute value of B minus C, which would be 2 minus 3, which equals 1. And the same for our third character. We could do absolute value of C minus D, which is the same as 3 minus 4, which equals 1. So we could then try to change this character as well, but we're already at our max cost. So if we did change this character, we know we would be above this cost, and that would be invalid. So let's look a little bit closer at how we can solve this. So let's look closer at this example. So there is a brute force way to solve this with just going through every substring of s, trying to convert it to t, trying to calculate the max length as long as it's under the cost, but this is an O of n squared solution and we could definitely do better. So we're going to use the sliding window technique in order to calculate this maximum substring. And we could do this in O of n time. So the general way that sliding window works is that while some condition is met, we're going to keep increasing our window by moving this pointer to the right and making it bigger. When we eventually hit some condition, say we'll keep track of our current cost, when this cost is greater than the maximum cost that we are allowed, we want to start moving our window from the left. We want to shrink it from the left. And why do we do this? So say our right was here, and we were above this max cost. If we kept moving this right pointer, we know that we just keep adding onto our cost. There's no way that the cost can get smaller by adding characters. So what we instead do is we take this left pointer and we shrink our window, subtracting out the values on this side. And while we do this, we can keep track of the length of the substrings that we've seen that are valid. We can go through the whole substring in O of n time doing this and basically always keep updating our max length. Then at the end, we just return this. I think as we walk through an example, it'll make a little more sense. So we're going to have 4 variables. We're going to have our current cost, and this is the cost to convert the current substring that we're looking at. We're going to have the left boundary of our window, the right boundary of our window, and also this max length. And this max length is what we update every time in order to keep track of the maximum substring that is valid that we've seen. And we update this max length by doing right minus left plus 1. So for example, say our right is at index 2 and our left is at index 0. The length of this substring is 2 minus 0 plus 1, which equals 3. And you can see using this example from 0, 1, 2, that's a substring of length 3. So we can use this simple equation to just keep track of this max length. So we're going to start with both pointers at position 0. And basically what we're going to do is we're going to try to process characters, add them to our cost, and once this cost becomes greater than our max cost, we'll start shrinking from the left. So let's see what that looks like. So we take this first character, we see that we could do a minus b, absolute value to convert this, which equals 1. So now we can add 1 to our current cost. At this point, we see that this current cost is less than the max cost that we're allowed. So we know that this substring here is valid. So we can add it to our, or update our max length rather, with that equation. So we know that our current max substring is 1. And at this point, we see that this is a valid substring. Let's try to make it longer and see if we can add even more and find a longer valid substring. So what we're going to do is we're going to update our right value and also update our right value here just to see it visually. Now we do the same thing with this character. We're going to do b minus c equals 1. What we're going to do is say, okay, update our cost, and now it becomes 2 because we're adding another 1. This cost is still less than our max cost, so what we could do is update this max length to 2. And since this is still less than the max cost, what we can do is update our right value. So we're going to move our right to 2 and also update our right value here. So do the same thing here. We do c minus d equals 1. We update our cost to 3. And remember, we can be up to this value. As long as we're less than or equal to the max, then it's a valid substring. So we see this is still valid. We could update the max length we've seen to 3, update the right to 3 as well, and then move this over. So now what we do here is say, this is valid. Let's see if we can keep adding to this substring. So we're going to do d minus f equals 2. So we're going to add 2 to our current cost, and this is now 5. So this is where we hit a different case, where the current cost is greater than the max cost, right? So should we update our max length? No, we shouldn't, because this is not a valid substring. We cannot count this. And we also don't want to increment our right, because if we keep adding characters, this cost is only going to get bigger, and we're just going to find more and more substrings that we cannot count. So what we're going to do is instead move our left. So what do we do when we move our left? So instead of adding characters on, we're going to take whatever is here and we're going to subtract it out from this current cost. So we see we had a minus b equals 1. So we can now remove that from our cost because we're moving our left to the right rather. We're no longer counting this as part of the substring we're looking at. It should be left. So should we keep moving the left at this point? Well, yes, we should, because we see the current cost to convert here is still greater than this max cost. We can't keep adding right characters because it'll always be greater than that cost. So again, we're going to subtract out this b to c value here. So we're going to make this 3. We're going to update our left to 2, then update this here as well. So now what do? So we see that our current cost is back within our criteria, so we can keep moving our left. So now what we're going to do, keep moving our right rather. So now we're going to move our right to 4. So now we've hit a different case. 4 is out of bounds. So in sliding window, once we get this right out of bounds, we generally want to just stop processing. There are a few cases where you might want to keep looking. For example, if you're looking for the minimum, we'd want to shrink this to find if there's a smaller substring, but here we're dealing with maximum. And we see there's no way from shrinking the left even further that we can make a larger substring. So we just stop at this point. So essentially at this point, we just return this max length. And the max length we've seen during this whole process is 3, which is our answer. So let's hop over to the code and see exactly how this is going to work. So as we said before, we're going to have 4 variables. We're going to have this max length. This is where we're going to keep track of the longest substring that we've seen, and also what we're going to return at the end of our algorithm. We're also going to have current cost. This keeps track of the current cost to convert the substring of S that we're looking at. Then we have our left and right, which are just the boundaries of our sliding window. So our while loop condition is while the right pointer is less than the length of S. We're going to keep expanding it. So what we do is at this current right position, we're going to calculate what it takes, what it costs to convert the character in S to the character in T and add it to our cost. And then this is the window, this is the area here where we're going to shrink our left, and only during the condition while the current cost is greater than the max cost. If this happens, we know that we can't keep increasing to the right because we're just going to get larger and larger and more expensive substrings. So we're going to subtract the value at our left and move our left up. Once we're back at a valid length substring, what we're going to do is we're going to record the length of that substring and say, this is a valid substring. Let's record its length, see if it's the longest one we've seen so far. Then finally, once we do that, we're going to move our right pointer and keep looking for larger substrings. So once we do that, we're just going to return our max length. So let's submit this and make sure it works. And it does. So hopefully this was helpful and you have a better understanding of sliding window. And thank you for watching.